Thank you all for coming. I'd like to introduce Andrei Alexandrescu, which for me, for many years, it was untouchable god. So I remember reading some of his papers in the late 90s from Dr. Dobbs and the C++ user journal, and of course. I would hope that many of you read his legendary modern C++ design, which has, for me, changed everything we thought about C++. And we ended up starting Weka.io about 4 years ago. We were looking for a programming language. And then, actually, quite accidentally, we stumbled upon D and decided to be an active user of D. If we have some time afterwards, I will tell you a bit more of what we're doing. And then I think 2 years ago, I met Andrei first time in the the 15 DConf in Utah, which for me was the closest thing to actually touching a god. I actually told you that. By the way, Andrei signed our copy of Modern C++ Design. Don't know whether any one of you got your copies, but I got my autograph. So, and I'd just like to say that we're honored to be a big enough user of the D language to be able to bring Andrei Alexandrescu over here and be able to share with you some of his genius ideas about software design. And I think you're going to learn quite new things on how you can think about software and how you can think about making your software on the one hand generic, but on the other hand unbloated. So please help me welcome Andrei to actually take the talk.
Hi everyone. There's one seat here, one seat here. For you, thank you. You're gonna hate me by the end of this talk if you don't sit. I can't tell how what I'm feeling right now. It's fantastic. I would like to thank Liran and Weka.io for this fantastic opportunity to visit Tel Aviv. Thank you. Many thanks are due to Google for, they took me like the 8,000 miles and Google took me like the last 150 meters to this, and plus 30 vertical meters. It's been like, you guys are a fantastic community. I've exchanged quite a few words with folks in the hallway before starting. By the way, I got some very interesting interactions with a couple of you. One person, I was in the whole minding my business, eating the great cookies and things, and so there's a gentleman coming and said, I heard there's a celebrity speaking. Should I recognize him? Where's that guy? I would like to start with an apology to that person. You're not getting a famous person. This is it. And the second interesting interaction was with a gentleman who asked me, like, let me ask you one question. Which language do you prefer, Rust or D? That's a serious kind of trick question level kind of question. Took me a while to kind of think. Actually, there is a meaningful answer to it, which is I like D because it allows me to do this kind of stuff, which we're going to get into right now. But by means of introduction, I would like to start with a few elements of the D language. Some of you never heard of it. It's like, oh, okay, so what's the deal with that whole D language? Some of you may know of it, but not much about it. So let's look a bit into what the D language is about. You guys see? I'm seeing a bit of whitewash here on the screen. Do you guys see the screen? Okay. Is it not too good? Maybe we can adjust the lights. It's not good on camera, it appears. Of course, if there's if this is gonna get darker, my face is gonna be more visible on the screen, and that's gonna ruin the whole video. So I hope you agree with me. I'm sure most of you are engineers in domains that have some performance demands that are not, quite a bit away from trivial. So you gotta do some systems level work, and there's this notion in economy that there's this whole notion of elastic demand for performance. What does it mean? Who knows? Who's an economist? Nobody. Okay. Who's sort of it? Who's sort of Uber? Well, he's not here, but you've heard of Uber, right? Uber went with an interest. Why does Uber work? Why is it so much positives and negatives? Anyhow, there's a lot there's a lot of enthusiasm both directions about Uber. Thank you. Uber started with the following premise: people use taxis once in a while, and the question is, if you put too many taxis on the road, what's going to happen? And the classic thinking goes, if you put too many taxis on the road, they're not going to get used, so therefore you're going to lose money. It's not going to be good. Nobody said, how about if we reduce the price per fare? Like if you continuously reduce it, what's going to happen? What do you think should happen? Yes, more people are going to want to ride the taxi, right? So it turns out this sort of goes amazingly much, because it turns out that the more you reduce the cost, the more people are going to want to take a taxi ride. So that's what they call an elastic demand. It stretches forever, right? So that's an interesting concept, and I'm sure you can take that to your own domain and tell me about some domains in computing that have an elastic demand for speed. Talk to me. There can't be nobody here. Yes. Storage. Thank you very much, Liran. I told him, like, if nobody raises their hand, Liran, have my back here. Yes. HPC. The more speed you got, the more things you do. It's not like, oh, so we did all the things we wanted to do. We can go home now. It doesn't go like that, right? Yes. Bitcoin. That's pretty awesome. Buy Bitcoin mining. Yeah. I've actually seen on eBay an announcement that they sell some machines that harvest for Bitcoins. I think it's interesting because they want to sell the machines. Like, here's the machine that makes money. It's like, there's something about it, And another thing that I saw in the news was there's this guy who has a system for winning the lottery, and he takes actually the algorithm, it turns out, is you take the past 6-7 winning numbers and you do like some XOR on them, and you get a next winning number. And he's gonna, I don't know the details because it only costs you $175 to buy it. So here's a system for winning the $1 million lottery if you just have $175 for me. I'm gonna sell it to you. That's kind of paradoxical, is it? Another domain with elastic demand? Yes. Network processing. A bunch of, the more the better. Guys, you are so, yes. Computer games, yeah, the more you have, the more you do. Everything you do on GPUs, there's a bunch of formal verification. If you want to check array bounds statically, array bounds violation, right? How long does it take on a non-trivial system? AI, yes. So AI is kind of, probably with AI we're kind of done talking about this, right? Because AI, the more you have, the more you want, and that's until it gets, of course, it gets a self-conscious thing, and it's I don't need these humans around me. They're kind of pesky. Anyhow, so you want to have performance, and therefore you gotta have this kind of stuff. No room below, no escape, all in the same language. You want to do runtime support, machine interface, base library, and this is where the buck stops. By the way, speaking of literally where the buck stops, there's a lot of use of high performance computing in finance, which I will note that nobody of you mentioned. Age of innocence, as it were, right? Like, you are engineers, nice people, right? So there's quite a bit of demand like that, and to be honest, like, just to kind of have a short parenthesis about what I think philosophically, if you wish, we're kind of on we kind of count down. We got to kind of really find the solutions to some problems that we have that are getting larger and larger. And the question is, are we going to have the time to build the infrastructure and the intelligence and the smarts and the capabilities that can take us over those problems? And we may as well not make it. And I'm seeing not a lot of smiles in the room. It's like, let me think. Actually, he's right. Oh my God, gotta go home right now. I have things to do before I die. Okay, so the design principles, you gotta leave no room below. There's no need for switching to other languages for cheating your way through. It's multi-paradigm balanced, it's practical and principled, which these may come in tension, as I'm sure all of us know, right? And you want to avoid arcana, and you know the joke with the turtles all the way down, yes? All right, I'm not going to ask anybody to say it to us because of the YouTube, but the short version is the scientist, the astronomer gives a public talk, and there's the old lady after the talk and says, all of this nonsense with stars and gravitation, gravity and stuff, and universe and black holes and what have you doesn't make any sense. It's all the whole universe rests on a turtle. And the astrophysicist, he knows what to say. He's gonna say, how about that turtle? What does it sit on? The old lady said, another turtle. And the guy said, okay, how about that turtle? The second one, what does it sit on? And the old lady says, you're not fooling me, Mr. Scientist. It's turtles all the way down. Right? So turtles all the way down in this context means some form of infinite regression, which I'm going to get into. But first, let me show you. Hello world, is everybody asleep yet? Yes? There's a couple of nice things about Hello World, which is why it's scriptable. Yeah? I can script it with Unix. Very nice. I'm importing some. Why do all this nonsense, right? However, it's simple, it's correct, and scriptable. But this already gets us, and it's amazing with very simple means. If you think turtles, you can get to interesting things all of a sudden. Because I made one little change to the program, aside from the shell line, which I'm going to not mention anymore. But I made a little change to this program. What is the change? Yep, I put the import inside, right? Okay. Should this work? This is my question to you. Should it work? This is a D language, not Rust. I apologize for not giving a talk on Rust right now. This would be the D programming language. A simple question is, if you had a language that did this, and you would try this, should that work? Would it be reasonable to make it work? You have a clean slate, open universe. Yeah. All right, does it work in C? Put an include inside the function in C. Yes. You did include inside, right, inside an if, yes. Actually, I call it a career limiting kind of thing to do, right? It actually may work. It may seem to work, because I think in C, if I remember correctly, you define a struct somewhere in a scope. It actually, it's hoisted automatically all the way up. I think struct inside struct, not, okay. And then function declarations just work in C. Function definition don't work. And then we have C++, which is another set of issues that may or may not work and may not seem to work. But anyhow, it's not something you do. Does it work in Python? Yes. Is it good? Yeah. Who says yes? Who says no? All right, 50-50. That's amazing, because I just read this debate in which it was 50-50. People said that's an idiotic thing to do, and 50% of people said that's a great thing to do. And it turns out the story goes, so I said, turtles all the way down in this context means I want to be able to do anything anywhere. I want to be able to put an import in a scope. There's no reason not to. There's got to be, the rules must compose orthogonally. It should just go, if it makes sense, make it work. So I call Walter Bright and I say, try to compile this thing, it doesn't work. So let me look in the compiler source code. So he goes to the compiler source code and he says the first line in the type checking for import says if you're not at the top level, error, abort with an error. So I said, comment that line out. And then it worked. Which is interesting because it's one of those things, it's not a feature, it's the absence of a limitation. Right? It's double negation if you wish, right? It's a bit that's zero, it's the absence of it that's interesting. The absence of the limitation that kind of, okay, so now I can do stuff with it. And guess what? So you have like visibility and stuff. But this kind of leads to even more interesting things. So people start using this and it's like, oh my God, this is so cool. So everybody rewrote their code to do import locally. And then there's like name lookup things. We fixed those, and there's some ambiguities and whatnot. So we kind of we got it really smoothly working. And then people started noticing that their code compiles a lot faster. We didn't do anything. We did nothing to make the code compile faster. How come it compiles 5 times as fast? Well, guess why? Because, because not only because the lookup is local, but because the import, this guy, is going to become, it became implicitly de facto and de jure, it became lazy. For example, consider what they call a template function, right? In this case, I'm logging things to the standard error output. So in this case, here's how you express a function template in the D language. It has 2 sets of parentheses. The first set is compile time stuff, and the second set is the runtime stuff. So T would be a type, and stuff would be any data of that type. It's the argument, it's the parameter to the function. So I need to import some things such as I want to import some date and time nonsense and the standard output. So I'm going to write to it the current time and whatever in the space and whatnot. Fine. So then I log this guy. All good. Yes. In other languages, would this work? Yeah, so there's a question. Do we do it during compilation, during runtime? Right. So yeah, so there's, yeah, it's again, it's kind of an open question. When would you do it? Yes. Who would do it during compilation? Who would do it during runtime? I can see not a lot of Ruby people in this audience. It's kind of not a balanced crowd. In D, you would do it during compilation. But even so, you would take every opportunity to not do it at all. Consider, I comment this line out and I compile the program, and guess what? I have a template function that is never instantiated. I have a potential function which is never realized. Would you, if you were an engineer working on such a system, would you ever open these 2 files or not? Never. Second question, if you're an engineer working on such a system, you had 2 functions, each of which imports, for example, the same file, would you open it once, 0, once, or twice? 0 if I can. If I get to open it once, I cache it. I mean, come on. We're engineers, we like cache. We like cache coherence and all that good stuff. I mean, they're the right keywords to live by, right? Until we, like, the sun goes, like, with all that, but that's, that's far in the future. And so we have this interesting situation by which you have a large library, and if you put the imports inside functions, inside the respective functions, all of a sudden you get like 5 times faster compilation because it's pay as you go, and you don't need to kind of import everything up front. Yes. Can you put it inside an if? Titles all the way down. You can put it in any scope. You can put it in a structure definition class. How it would work? Open the question to the audience. How does it work to put an import inside an if? Instead of in a loop, I'm going to put it in a loop. No, I'm going to put it in an infinite loop. Okay? How does it work? Yes.
If it is static, you will do it once. If it realizes, if it is an if, a runtime if, then you have to include it. I believe so.
Thank you. I was afraid for a minute. Microphone is the most important weapon of a speaker. If you have the microphone, you can you have all the right answers. So, yes, if it's in an if and the function gets compiled at all, you're going to import the file because the if is runtime and that whole compilation stuff is compiled. It's way earlier. If you have a loop, obviously the same problem. Lookup is different from you don't actually run the whole thing, even if the loop is never realized. It's never executed even once. All right. So we got to this interesting state of yes. Okay, awesome. Thank you very much. Let's say I make a typo in the log function and I never use it, right? So it's like the tree in the forest, yes? Right? What should happen? What should happen? Should there be an error during compilation? Yes. Probably depends on what type of error. So let's say the code is syntactically okay, but it's just not semantically valid. So let me submit to you, let me open a parenthesis here and submit to you the following piece of evidence, the piece of evidence, say I'm gonna bring in a plastic bag right now and submit to you hello world in C++. How many lines does it have? Yes, how many? The program hello world in C++ is using cout. 3 lines, more like 45,000 lines. With Clang, with GCC is larger. We get a few megabytes of input to the compiler after the preprocessor has done its job. Okay. While the preprocessor includes all that stuff, there's good stuff in there. I mean, I consider this, so consider like, don't take it the wrong way, okay? But let me show you what the compiler must do, what must happen for get hello world to run. Actually, not only C++, many languages, but in C++ in particular. So you have this preprocessor running, which produces 20 megabytes of output. And that gets compiled by the actual compiler. The text that the compiler sees is 20 megabytes, right? So, the compiler is going to be able to rummage through the thing in like 0.3 seconds, which is amazing. It's an amazing feat of technology. Why do people say C++ compilers are slow? They're the fastest text treatment thing in the history of humankind. I'm not kidding. They're amazingly fast. And then it gets to the linker. Who knows how a linker works? Don't raise your hand. Do not. Nobody should raise their hand. No, nobody's. It's okay. Nobody knows how a linker works. Okay. So then it goes through the linker, and the sheer fact that this whole thing completes in like half a second gives me hope that we're gonna get to have AI. Right? Yes. That code, well, yes, that is correct. So that's why if false is going to still import the file. Templates are, thank you for, I think I understand the question. So templates, when are they instantiated and what are the laws governing? Instantiation is lazy and only done by the front end upon the first use, right? And then at that point, you're gonna have the whole thing triggered. So there's, okay, so we are at the 45,000 lines, okay? All right, so now consider this. Those 45,000 lines are going to contain a bunch of templates in the text, right? Because there's the console, the string, what have you, right? And now we're looking at the following interesting prospect. We have these 45,000 lines, and it completes compilation like half a second, linking everything. Awesome. Now consider this. What if we have an extra step, type checking all the templates that are not instantiated ever by the hello world. How long do you think compilation is going to take in that case? Actually, let me rephrase. Do you think compilation is going to be faster? In the uninstantiated templates, nobody hears them. And that's why. Because you want to distribute large template libraries without inflicting the pain on your users. The pain of paying for what they don't use. I think, honestly, I think the whole thing of we want to check all of these unused templates is missing the point, because you don't want to release code that you never instantiate, because that's even worse than releasing code that you never test. It's not that I don't want to test it, I don't even want to use it. I'm giving you code. You see what I'm saying? I'm giving you code. It's not that I don't care to test it, I don't care to even compile it. So that's amazing. Back to the main point here. Where was I? And guess what? So okay, so you go through all this stuff with imports, turtles. Okay, very nice. And then all of a sudden, link times are faster. So again, I don't know how linker works, but I have a few thoughts, which is like, whenever you link, there's object files and there's library files, right? So the object files, so you load the object files and you patch everything that's the symbols, the references, right? And then what's the next step? Some symbols are going to remain unreferenced, unresolved. What do you do then? You go to the libraries, you pick the big guns, right? The libraries, which is you look in the directory, LD library path, right? Now, come on, you're engineers, you know what I'm talking about, right? And then you kind of open files, search directories, open files, do things, do a linear search through each library until you find one. And when you find one, it's like, okay, thank you. So you patch the thing and you're done linking, right? That's the long tail that's the long stage of linking, is the whole library searching thing. The object files is really fast. You have your own structures, you do it quickly. And with templates, you have more things during compilation and fewer things during linking. So yes, you spend more time on compiling, but less time on linking. And guess which program do you understand how to improve? Yes, gold notwithstanding. All right, so you get to parallelize, yeah. So all the good things you can do, which are much more difficult for a linker. All right, variadics, there'll be some, you just dot, and it just explodes there, expands. Nothing interesting. RDND is a nice script which kind of takes care of all the all the dependencies and all caching and everything. So, but that's not important. What's important is the next step. We want to kind of do something that's a real thing, not some of the simple things. So I'm going to discuss a bit design patterns. Who's heard of design patterns? Which were like most of you were born, like they were like after being famous by the time you're born, right? So design patterns have had a heyday in the 2000s, and people like there's a pattern for eating pizza by a programmer, like pattern for everything. Whatever you do, oh, that's a pattern. Write it as a pattern, and there's like a LaTeX template for it and that kind of stuff. PowerPoint, what have you. So it was kind of ridiculous. And then people say, oh, I hate patterns and everything. Singleton is like the most awful pattern in the world, which it is. I mean, I'm not contrary, it is. But also, if you Google for design patterns, Singleton is the first that comes, right? Which is, it's kind of interesting. It's like the O.J. Simpson of patterns. So, so now we have, we have kind of the dust has settled by this point, and we have some influence on design methodologies. One of which being influenced by patterns. What I noticed is that everybody who was big in patterns moved to agile and Scrum and stuff, which is cool. Okay, good. So now we get to policy-based design, which I was very surprised. I looked over like a couple of weeks ago, and I discovered it's been inducted in the Wikipedia Hall of Fame of Programming Paradigms. So if you go here, you're going to see policy-based design, and it has its own page, and it's amazing, and it's pretty cool. And I was flattered, but it's this. I didn't invent this, but I named it. So the thing is, I was flattered, but not in a good way. This kind of attention is not awesome. And then so I was looking for this, and I was like, okay, so this is very nice, but actually, I think things could be done a lot better. And that's kind of a high charge to make, a high claim. So anyhow, to get a comparison going between design patterns and policy-based design, they approach the same fundamental issue, which would be, I have some code for achieving certain results looks the same way over and over again. So I'm going to give it a name and encode it. Fine. In patterns, the programmer would be the generator. It would be as simple as you type it from your mind because you have an understanding of how the pattern goes. And in policy-based design, the program controls the generator. To wit, Mark Dominus. So great thing. The design pattern solution is to turn the programmer into a fancy macro processor. They had me at the first syllable in fancy. They had me fancy macro processor. And they have all the right key. I would marry that thing, right? They have all the keywords in place for me to get excited. If it's fancy, if it's macro, if it's processor, I want to automate that thing, right? I hope are you with me? You don't want to do it by hand. Come on. Why would I be the fancy macro processor? Because when I cannot write a fancy program that does the said fancy macro processing. So this is kind of shocking. So then in policy-based design, you automate that kind of thing. And let me introduce you to just a bit of simple decode. Just to illustrate things for later, we have a struct widget which takes like 3 template arguments, and I'm going to store them as simple data members. And we rely on implicit interfaces, which means I write the field name, I write dot method call. And if it works, fine. If it doesn't compile, time error. And how do you call that kind of typing? Implicit typing of interfaces. Duck typing, right? Duck typing, which means if it quacks like a duck, etc., and it's right, it's not a mammal. So fine, great. So you rely on implicit interfaces. You kind of define these implicit interfaces to kind of follow the strategies that you want to pursue. And the interesting first, there's it's become kind of trivial, and it's totally so. But there's some interesting thing that I want us to keep in mind for just a few minutes later, which is there's some multiplication here occurring, because changing one of these is going to kind of multiply the number of possible behaviors. So by playing with these guys, I'm achieving some combinatorial kind of thing. Do you agree? Product type. So it's kind of a product type of 3, possible dimensions. Okay. So now there's this really weird thing that I think I have another one. I think I have another program paradigm. It's a huge claim to make, and it's very. I can't tell you how much it pained me because I've been sleeping for this. I can't claim this. It's for me, like personally, at a sort of a mammal level, I was very scared to pretend I found not 1 but 2 patterns. I mean, it's like, nobody of those 76 program paradigms, there's not 1, there's not 2 that are by the same guy. You see what I'm saying? I mean, it's ridiculous to say, actually, I have 2 in me. That's fine. It's for some reason, guess what? Actually, that reminds me of a story. When I was a kid, so that takes me to the beach. I was on vacation, and I'm, playing on the sand and stuff, and I find a crumpled piece of paper, which turned out to be a 50 Deutschmark bill. Like, oh, interesting. I was in communist Romania, so 50 Deutschmark bill was like a house. I don't know. It was like a huge thing. Okay, like amazing. The hard currency of the Bundesrepublik Deutschland, right? It was like a huge thing for me. So, oh my God. And for that, it was a huge, oh boy, you're a lucky boy, awesome. So keep it for college. So then, okay, so the next day we're playing a different beach, different area, different everything. I find another one. And I go to that, and that Pops goes like, hey, boy, where did you steal all that money from? Where did you steal the money from? And I learned two coincidences in a row. I mean, I may have one thing on the programming paradigms, but two is very unlikely, right? So it is with great trepidation that I'm mentioning all of this to you right now. It is with great emotion. And, you know, I might not make it, you know, you're going to kind of lynch me or something, you know? So please be patient and be merciful. Design by introspection. So, who knows Richard Feynman? Yes, I almost divorced my wife because she wouldn't know who he is. Said, honey, you gotta go Wikipedia, you know, right now. Okay. So Richard Feynman had a very important paper, a seminal paper called "Plenty of Room at the Bottom," and the paper says, what would happen if we could arrange the atoms one by one the way we want them? And that paper launched the whole domain of science, which is, thank you, nanotechnology. So he made the argument that actually we could, you know, there's this whole creating molecules out of atoms thing, and it's actually very difficult because the way we create it is a macro level. We throw in the ingredients, you know, we throw in the catalyst, whatever you have, you throw in the like energy, and you hope that that whole barrier of potential, you know, between bonds and stuff is kind of reach and kind of push, you know, mash molecules together, like that kind of stuff, right? And it's difficult. But actually, if you kind of take the molecules hand by hand, kind of avoid carefully that barrier of potential, it's easy to assemble any molecule you want. And he made an interesting point that you're not breaking any laws of physics by doing so. It's entirely possible. You could do things by hand, except there's a problem with the hand. It's too big, right? So he said, what if we found like the person who has the smallest hand in the world? Not enough, right? So then nanotechnology was launched, right? So that was the motivation of nanotechnology. It's actually you're not breaking any law of physics by allowing this to happen. So then, you know, that got me thinking, what would happen if I could arrange elements of design, of programming, of not programming language design, of program design? I could arrange them hand by hand instead of just mashing them together and hoping it kind of sticks to the wall. And let me give an example. Actually, Liran saw this this code and he said, actually, I have the code example for you. And he pulled one of his slides. This is production code at Weka.io, which goes the following way. They have a Robin hash table, key value, and it has a maximum length of the table. And it uses an interesting device here, which is called static if, which means during compilation, evaluate the following expression, which can be an arbitrarily complex expression. And if so, then essentially pull this code into the enclosing scope. So this is not a scope. This doesn't introduce a scope. It just inserts the definition at the same level as the static if itself. So if that condition is met, I'm going to define the cell IDX type to be use short, unsigned short, 16 bits. Otherwise, I'm going to alias it from uint, which is 32 bits. Great. And then I'm going to do an interesting different test, which is, well, how about the size of the key? Is it less than a multiple of 8? Do I get 1 byte at least after the key? In which case, I'm going to massage in the structure. I'm going to massage a key and the U byte that they need for nefarious reasons, I should add. I saw their code. All right, and then I put a value. Otherwise, I'm going to put the key, the value, and the cell data. Right? So, question for everybody: how many possible layouts can I generate with this code? Yes? 4. Thank you. 4, because for each of these conditions we have one possibility, and then they multiply by the by the number of possibilities and every others. So roughly, by counting the number of static ifs, you count the numbers of possible designs. And this is putting together a simple structural design by hand. You would need to write it 4 times in a traditional manner. That's an interesting piece of information that we could use. So that takes us to the core idea that I want to submit to you. Humbly, I should add. This is like, it's surprising to me that this is happening. Well, in patterns, you have a mental macro that you expand. It's like, I want to write a visitor. You write a visitor, right? And it takes longer than that, but right? You write a visitor, or observer. Oh, what kind of observer? So there's a lot of things you can do, and whenever you want to do something different from what you did before, it's in your hands. You do it. In policy-based design, it's not like that. It's like, oh, I have some macros, some predefined behaviors, I have some duck typing going on, and kind of assembling them, and I'm going to make it work that way. So in the first case, I have total flexibility, plus I can do whatever I want, but I don't reuse any code because it's all in my mind, from my mind to the keyboard, and it's not reusable. In policy-based designs, there's no plasticity. It's kind of a more rigid approach, but you get a lot of code reuse because that's nice. In policies, you get to reuse them. In design by introspection, the premise is you should be able to do the best of both. You should have plasticity and reuse at the same time. If this is too abstract, don't worry. I do have an example, and you're going to hate me after this example. So before getting into it, what do you think the input should be to such design by introspection mechanisms? Well, you should remember those static ifs and stuff. What's the input to those? Yeah, so it's types and properties of types. I mean, these are very simple, but you can actually do a lot more introspection. You can ask a type, well, what do you know how to do? What's your size? What's your alignment? What's the deal with you? So the input in design by introspection would be, you want to introspect types. You want to ask a type, what's your deal? What are your methods? What are your fields? What's your alignment? What's your size? What's your deal? Ask this during compilation. A variant is a simple query. Do you support a method by that name? That's a simpler version of input to a design by introspection. And then I want to process things during compilation to create designs. What kind of processing do you think I need? Anything. I want to do arbitrary things, such as you give me the regex, I'll give you the pattern matching engine that's specialized for that regex during compilation. Okay, that's what you give me the EBNF grammar, I give you the parser for that grammar during compilation. This is the processing is like arbitrary. You gotta create objects, create arrays, whatever you do, hash tables, everything's gotta be in there. Should you be able to write files? System call, can you call system during compilation? Why not? Turtles all the way down. Remove -rf, like slash, right? You probably don't want to do that. Yes. Yes. Thank you for asking. So the compiler may actually not terminate. The compilation might not terminate, right? Because obviously we're dealing with doing complete processing during compilation. And you know what? We're fine with that. Yes. The compiler may not be deterministic. Sorry? Actually, the compiler is deterministic. Sorry? Reading the files is not deterministic. Oh, that's kind of getting deep. Oh yeah, so yeah, you read files. You can read files during compilation. We should take this offline. I think there's something there, but kind of, you gotta live with it, right? Actually, you brought an interesting point, which is there might be rare conditions. There might be race conditions during compilation. because in D, all declarations are entered. It's not because of that what you think. No, it's a different thing. In addition to yours, I'm not contradicting one. So in D, you can do sort of a race condition because all the declarations are entered simultaneously. So whenever you declare functions and things, you just enter everything in parallel. Whoop. So then you may have like something that does some introspection, defines a variable. You can have like a sort of a race condition depending on which executes first. That's an extremely rare case, and we're not detecting it because it's the halting problem. The day we take care of that, I'll let you know. So here goes. So processing, we don't want to do arbitrary compile time evaluation. Like really anything. Loops, you name, create objects, arrays, grow, push, grow arrays, whatever, hash tables, you name it. Of course, no system calls, please, ladies and gentlemen. Right? There's two ladies. Like usually I have to say like lady and gentleman because it's like one. Right? There's two at least. So there's quite a okay. So ladies and gentlemen, you please no system calls. So you can't do that, right? So turtles, but not any turtles, not the bad ones. Okay? Great. So DBI output, what is the output? Program, code, yay! So we have program, we want to generate any code we want. Question, what languages do this? Of the ones you know, on the ones on your t-shirt. Pascal? And it may not be all of these things. Yes. C++. 17. Does it do this? 20. Whatever it is, it's going to be like, all right? By the time this compilation finishes, we're going to have C++ 20 and, other, yes. Sorry? Fourth. Actually, that's kind of cool. Fourth does do that because you can't really distinguish when compilation and runtime happens. So it's kind of a cool language. I read once an article, I was, oh my God, I'm going to do fourth for the rest of my life. And then the next afternoon, I kind of forgot. But that's, well, that's pretty awesome. It's an awesome example. Lisp, okay, Lisp we shouldn't mention because it does everything. Like everything is in Lisp. Like, every feature ever invented has been in Lisp since like 1960. So we're kind of done. We don't need to mention it. It's, by fiat. It's there. Yes. Okay. Yes. In Haskell, kind of, have the opportunity. I don't think you can query, right? That's not Haskell. Template Haskell. Template Haskell. That's not Haskell. Did I say template D? Right. Okay. So yeah. So Haskell does all languages use some of these things. I don't think most do what we need here. So, well, of course, there might be a language that would be of interest tonight. Input, actually, D has extensive introspection capabilities. As the tuple of gives you the layout of a type. You say type that tuple of it just gives you there's an int, there's a float, there's a string, there's a long. Have a nice day. There's a traits keyword which gives you a variety of traits. Query for do you have give me all members, list me a member. Give me the function signatures, etc. Overloads like everything. All right, processing. Oh, guess what? D has a thing called compile time function evaluation, which means whatever is a function, if you try it during compilation, it's just gonna work. Which means the compiler has an interpreter that runs during compilation. You can do like amazing things with it. And then there's this whole static if business, which I showed you a bit of it already, which is some sort of a very enabling little thing, which continues to amaze me. So, okay, so I come to Israel, I come to Tel Aviv, I meet these guys, I'm kind of looking over Weka code. And I'm not kidding. Every 5 lines, there is a static if in their code. Is this an exaggeration? I say all over the place, like static if, static if, static if, right? And they're like good engineers. It's not like they're like kids who are like, oh, we found the static if thing, so let's use it everywhere. Like I did when I found try catch. Remember the days? I was like, oh, exceptions. I'm gonna every function would be a try catch. Everything was a try catch back then. It was awesome. So, okay. So this whole static if thing, consider what does if do during the regular? What does if do? It does a sort of a time fork, right? A non-deterministic, it's kind of nicely, you choose this or you choose a different universe in time. So you kind of, demultiplex things that could happen in time. So you double the behaviors that could happen in time, right? Now, take it to compilation. What does static if do, therefore? Ladies and gentlemen, what does static if do? Create different programs. So whenever you use static if, you double the number of designs you cover. You're like, whoop, you fork. Oh, and then whoop again. And then 5 lines later, whoop again. That kind of stuff. That's why they have static if, because they have I'm not going to say how many lines of code you have, but they have amazing functionality in like a fifth of the regular code, because they always use static if whenever appropriate. So we have this nice processing. And what's the output? We're going to have something interesting. We have a regular template expansion engine in D, which is akin to C++. And we have a more interesting mechanism, which is called mixin. And to mixin, if you pass a string, it's going to do something brutal. So you pass a string to mixin. Let me, can I write on this whiteboard here? I can't because I don't have a... Oh, Herr Professor, thank you. So we have the right person here. All right. If it's permanent, I don't care. It's Google. Thank you very much. I hope it's not permanent, right? Yes. What? Oh, thank you. Okay, so I don't know. If you say mix in, is somebody? Oh, it's like AI. This table is AI. Is just moving. All right. So if I write mix in, and I say X, like an idiot, what's going to happen? Well, here's what's going to happen. Mixin is going to take this string, whatever it is, and it's going to pass it to the compiler as make me an expression out of this. And all of a sudden, it's a very fancy way of writing X. All right, so I'm not an idiot. I understand this is kind of not what we care for, but consider this. Consider I'm mixing something kind of function call. So fun returns presumably a string, and so then the string is going to be passed to the compiler, and the compiler does whatever the hell it's supposed to do with that string, considering it code. Well, the plot thickens, isn't it, ladies and gentlemen? All right. How about this? Make parser. I open a parenthesis, and I'm gonna do something. You're gonna hate me for this. I open a string. You can put enters and stuff, no problem. So mix in make parser, and then you have something like expression is what's an expression? Grammar, term plus term. Yes. And what's a term? Factor times factor, right? And this may be optional, that kind of stuff, right? So I'm writing my EBNF grammar, and then I close the string, and then I close one parenthesis, and I close another parenthesis, and I put semicolon. And this guy, make parser, actually exists. I mean, there's a human being who wrote this function. His name is Philippe Sigaud. He wrote a thing that takes your grammar and makes it into a parser. And you have like 6-to-1 compression between like the source code that you would need to write by hand and the actual grammar that you need to write. And this is happening during compilation of said string. So mixing is kind of really sort of, it is disconcertingly powerful. It's so powerful, for a while people didn't know what to do with it. Because like you have a chainsaw in your living room. It's like, maybe I shouldn't touch this, right? And actually, the comparison is gets even better because, It is a primitive tool. It's any string. What would be the civilized way to do it? Some sort of an AST macros, AST like user-defined syntax, and AST manipulation and those nice things. How many of you are experts in abstract syntax tree manipulation? For a while, yeah, it's been a while. So, okay, one person in the past, right? So, how many of you can do string manipulation? Everybody, don't need to. Like everybody has done string. We kind of discovered that doing it the dirty way, which is kind of is ridiculous. And whenever a programming language person looks at this, it's like, ugh. Okay, right? It's like, oh my god, what did I do here? Didn't you hear about AST macros ever? But actually, it's a very good way to bring code generation power to the masses, to the blue collar engineers, right? Quite literally in this case, right? Yes. How is it different from just running a Python script that generates C code? Yes. You do it in templates, but what's the benefit of it? Sorry? Thank you. So I think you're aiming at the following response, which would be mine. The answer is integration. So this whole thing is highly integrated with the language, so you can actually pass into these variables that you have in the source language, and you can get back communication with the host language organically because it's there, as opposed to separate code generation. Of course, in certain cases, you don't care for that, so you just generate the thing separate and interface it with standard means. All right. I'm not going to talk a lot more about this, but I think it's a cool thing to keep in mind. That whole chainsaw thing. So once you have introspection that's done during compilation, you get a very interesting consequence, which is optional interfaces, right? So traditional interface, like I have these n functions you need to implement, and please implement them all. And that's the contract. You define the interface, defines the interface, and the implementation implements said interface, right? In design introspection, you don't care. You just say, please implement a few required primitives, and everything else is optional. Okay. So you don't need to implement them all. You implement what you can. Let me ask you this: if you have n optional functions to implement, and you could implement any subset, I'm actually making myself big. I want to stand between you and the screen so you don't see the answer. It's gonna be here somewhere. If you have to implement any subset of n functions, how many possibilities are out there distinct? Power set, thank you. Power set, which is what size does the power set have? You can see here. Okay. All right. So you can implement, the possibilities are not limitless, but are 2 to the n. So it's a power set which has an exponential size in the size of the interface. So with a very compact form, I just specify n methods, each of which is optional. I specify 2 to the power of n possible implementations. Interesting. And that kind of, this whole thing there's depth to it. It's not trivial. Because traditionally, when I say I didn't implement this particular primitive in my interface, I don't know how to do it, right? So that's usually it's an error. It's like, you're wrong. Your interface implementation sucks, right? It's like awful. I can't use it. It's an error. It's a mistake. But in this approach, you'd go like, well, wait a minute. The fact that it's not implemented is the absence of information, which actually is information. Right? When something is not there, there's information that it's not there, right? So from a very practical perspective, you're like, oh, okay, so this function is missing, so there's a bit that's 0, and I make decisions based on that 0, right? So then we cover exponential possibilities within your code. you can get state variations as we saw in the example with the hash table. Static if being the magic design fork, no penalty for large interfaces. You can define the interface as large as you want, as long as it's all optional. And you have graceful degradation, by which I mean the following. In the traditional approach, if you don't do something, you can't use it. You gotta implement the whole interface. Here, if you have less capable components, you're gonna get fewer features in the, in the larger component that you're gonna build. Let me illustrate by means of an example. But first, don't forget, if you have any power to influence people who define the languages you're using, this is crack cocaine. Okay? You wanna be there. If you wanna be there. You wanna do this. Okay? All right. So we have three. So again, because I was very afraid, I did the same design 3 times, and the same idea 3 times. One is there is a thing, if you Google for this, you're gonna find an allocator for the deep programming language, and it defines pretty much any allocator you can imagine in 12,000 lines of code. Now, 12,000 lines of code is kind of a heavy proposition, but also memory allocation is it's quite the domain, right? By the way, if people are leaving, because I somebody coming back, they're always going for cookies, right? They come back, right? There's nobody leaving in protest here, right? You have agreement. That's how I'm thinking of it, so I don't like cry on the screen, like, oh my god. So, by means of comparison, there's an industry strength allocator which is called JMalloc. It's not a French allocator. It's not JMalloc. It's not that. It's written by Jason Evans. He's a friend. He's a great guy, and this is pretty much like the best allocator I can imagine in the world. And he wrote one allocator which is replacing malloc and free and realloc and in the gang. And it took him 45,000 lines of code in the C language. Of course, it's hard to make a comparison, but his is one. The experimental allocator is like really literally any allocator you can imagine, you can do it, right? So this stacks well. Collections, please take a look at the DConf 2017 talk by Edward, who's talking about the collections library that's pretty compelling. And now I'm going to insult your intelligence right now, because we're going to discuss checked integers. First of all, who's here from Mozilla? Did you work on Mozilla? Okay. You use Mozilla. Okay, one user. Okay, great. Who is anyone working? Okay. Cool. Yes. Yeah, please. If something goes wrong, what is the code that's actually not even running generated, right? Okay. Have you heard? Who's heard here of the phrase debug by printf? All right. So in the D language, there's a primitive that allows you to you put it inside the static if, and if that code is generated, it's gonna print something for you. And you can print any string. It's you can print like arbitrary, like type names and whatever. And this is one, this is a primitive that people use to debug their code. It does require. I'm not, it's not all like smiles and happiness, right? There's a bit of like, you can, with this much power, you're gonna cut a finger once in a while. Okay, you're gonna cut a finger once in a while. All right. So indeed, and people talk about debuggers during compilation. There's somebody working on that kind of stuff. So, yeah, I want to debug my design by my introspection. By the way, so it's you gotta measure, you gotta test things differently and debug things differently. Just the same as remember the days of procedural programming, and people started object-oriented programming with virtual calls. And people, the procedural folks said, "Oh, this is crazy. We can't test this because I have no idea what function gets called." So then you had the whole new testing methodology, and this is going to happen yet again. Yes, there's a question. How can we test the exponential behavior? By using the same techniques in the unit tests. You cover exponential behaviors by using the same exact techniques in the unit test, and that's exactly what we do. Right? You use the same tools, right? How do you cut a diamond? With an even stronger material, right? So that's how you go about it, right? Yes. How does the unit test execute? It may take a long time, right? So if you want to test all combinations, it's going to take a long time, right? So people, what they do, they kind of reduce the space. They say, I'm going to do something polynomial here. I'm not kidding. So actually, it's a thing, right? Right. So thank you. Unit tests are part of the language. So there's a very easy way to superpose unit testing with the. Yeah, it's part of the turtles. You can actually unit test anything anywhere, and actually you can unit test template instantiations only when they occur and stuff like that. Anyhow, well, who's using integers? Okay, who's checking all of their integral operations for overflow? Right? You're funny. Okay, I'll tell you what you need to do, just in case you care, once in a while. Well, these operations, plus equal, minus equal, plus minus, star equal, may lose information. Overflow, truncation, what have you, right? You may divide by 0 whenever you divide. So that's another check you may be mindful of. What's wrong with the most negative value of a signed integer? If you put a minus in front of it, what do you get? Itself is the identity function for that guy, right? It's awesome because it's negative and you put minus. Oh, if it's negative, x gets minus x. That's what we all write. And then we're confident that, oh, whatever follows is going to have a positive x to deal with, except this one case, which kills you, right, when it happens. We have some clowny rules from C, which is like -1 is the same as the largest unsigned integer. And things like -1 is greater than 2 unsigned. It's kind of unpleasant. It's quite, quite a bummer, and it would be nice to have a warning for that kind of stuff, right? You know the C rules for conversions during compare. Okay, no, don't, no. Okay, whenever somebody tells me they know, I destroy, because I know one thing that nobody knows really. It's system dependent. So conversion result is a system dependent. It's just crazy. You can come to me after this and kind of, have a punch fight right now. Okay, anyhow, one of the C rules which D actually inherited and C++ also inherited is the following. When you compare a signed integer with an unsigned integer, when you compare two numbers, if an unsigned integer is within a 1 mile radius, then everything gets converted to unsigned. That's the rule, right? And they measure the 1 mile to the micron, okay? All right, so this is what you need to be mindful of in integral arithmetic overflows, and that's pretty much it. So then, well, how about we don't care for that nonsense, and we put the whole thing in the programming language and it takes care of it. It's just gonna throw or kind of use unlimited length integers. Who knows of languages that do that? What languages would do that? Python, infinite precision, Ruby. Like all the civilized people, like the polite company is gonna do that, right? Like they can't care for that nonsense. But if you want speed, you can't do that, right? What the other solutions? What does OCaml do? OCaml fans? Oh, this is a self-selected audience. Yeah, OCaml, I'm not gonna go to that nonsense. OCaml does something nice. They have 31-bit integers, and 1 bit is reserved. So when that guy is 1, you switch to the long representation. Great. So another thing is like what C would do, because in C we're like real men and respectively women, and we're gonna like do it the hard way, right? Just insert the test by hand. And if you search for Linus meltdown, I'm not kidding. This is like an awesome coincidence. If you search for Linus meltdown and you look for kind of news, social media news or whatever, I mean, if you search for, so you're gonna get like 1 billion results. Like Linus meltdown, gonna make many of those, right? But if you look at the most recent one, you're gonna find that there's a guy who introduced like an overflow check, and he called a function, and it was kind of an arcane way of doing overflow checking. And let's just had a field day with that guy, mop the floor with him, and it was an interesting use case of testing gone wrong. So anyhow, that's kind of a difficult proposition. If you ever sat down and tried to convert the whole function to do this, it's just triples the size, and it's like awkward. You don't understand what it does anymore. It's just ridiculous. I actually tried it as an experiment to kind of, let me take this 20 lines function. How bad can it be to insert tests for everything? It's really very bad. All right, so not good. How about this? We have operator overloading. In what languages? What languages define operator overloading for types? C++, Perl, Python, C#, F#. What else? D. Somebody said D. Yeah, amazing. Yeah, so a bunch of languages do it in nice ways. So that would mean I'm going to define a type that does all the checking automatically, and I'm going to use it whenever I need that checking, right? Sounds like a nice proposition. And I have quite a few challenges. What do you check for? Do you check for everything? A few of them? Maybe sometimes you don't want to check, you want efficiency. So it's kind of a toss at exactly what you want to check. Then whenever bad things happen, what do? Do you write something to standard error? Do you abort the application? Do you throw an exception? Do you log something? Do you fix and approximate, saturate, not a number, do what the floating point numbers do? Which they're very they never protest. They always, I'm gonna be nan from now on. For my lifetime, I'm gonna be nan. I'm cool. And go in the corner there, be nan. No problem. So how about type system integration, conversions and all that stuff that's happening in a large programming language? And you want to make it efficient, which let me insist a bit on it. What's the efficient way to check for overflow in an integer operation? Don't do it. Yes, that's the infinite speed, right? As zero cost. What would be the second? Okay, the second most efficient way. Cast to 64 bits. What if it's 64 bits? What if it's already 64 bit? 128. What if I can play this all night? You take. Or what if I told you there's a much simpler way? Yes. Thank you very much. You guys talk to each other. Architecture dependent. So it turns out that every processor, they care about that kind of stuff. The hardware people, whenever an overflow occurs, they feel bad about it. I'm going to set a bit somewhere in the CPU to inform you that actually something embarrassing happened right now. You had this multiplication going and it didn't go as you expected, right? So there's a bit, which you can easily test with like a line of assembler. And we're going to take that sacrifice of, I'm going to have a line of assembler in our 2 million lines code base. We're cool. And that's the fast way to do it. There's no other way to any other way, they don't know what they're doing. But if somebody sits down and defines a checked integral type and they don't do that bit, they're not doing it right. Okay? All right. So then we want to make the whole thing small. Yes? So as a programmer, am I supposed to do the overflow checking myself, or is it going to be an exception? The thing is, you take the bit from the CPU, and then you take it to the high-level code, and then you decide what to do, throw an exception or whatever, right? So essentially, as a programmer on a platform, If you're coding in C#, there's not a lot of assembler access. So maybe you have a system primitive in somewhere that gets you that bit. You got to get that bit to make it fast. Otherwise, if you don't care about speed, it's no problem. Checked and unchecked. So math is checked okay, cool. Thank you. So math is checked in C# check blocks. You have the overflow check, and that's gonna throw, right? It's gonna throw. All right, get back to me. Google for it. All right. The default is even in check code, the default is unchecked. Okay, not my language. So make it small. The whole thing is that these things can get big real fast for odd reasons. Now, it's no problem if you tell me what to do, I know how to do it. If whenever that happens, you're gonna throw an exception. Whenever that happens, log something. Whenever that happens, do this, right? If you tell me one behavior, I know how to implement it. It's gonna take me 100 lines of code. I'm good. Now, the problem is, how do you allow behaviors that are as of yet unspecified? You don't know what you want to do because you're writing a library that allows other people to do things that they want to do. So this is where the challenge starts. And we have like these generic libraries that come with a sticker shock. And I quote from memory from a forum post, you mean I need to use 5,000 lines of code library that comes with a 20-page manual? All I wanted to do is A plus B, does it overflow or not? Why are you giving me this, large library for this small thing? To wit, I have a few baseline to show you. First, Mozilla's checked in for C++. It's very small. It's 800 lines of code. It does rigorously all the wrong things. That's why I asked. It almost like to the T, it does all the wrong things in the right order. Oh, well, it has an inefficient layout, so whenever I have an int, it comes with a bool next to it. Oh, I have two ints now to worry about. So if you have many of those, you have a problem. So the layout is messed up. That bit is something happens sometime, and you look at it. It's pretty much like, it's just one small step up from the CPU bit. We take it from the CPU bit and we put it like next to the integer where it's gonna bother you. So there's no configurability, you gotta do everything by hand. It's incredibly inefficient. I have the suspicion it started as an April Fool's joke. They had a contest who's gonna write the least efficient code that does that kind of stuff without writing loops. Because it's not loops, but it's just as bad as you can get without loops. In order to make sure that I have some, anyhow, so in order to check that an addition would overflow, they do it once. They do the reciprocal. If it doesn't, okay, it works, fine, let's do it again. So it's kind of really, if you don't care about efficiency at all, and you want something that's big, and you want to do all the work yourself, that's your library. You gotta choose that. And we have the kind of the opposite end of the spectrum. We have the Death Star of checked integers. Microsoft, SafeInt, 7,000 lines of code across like several files. I forgot the number. As I think Bill Gates worked on that. Right after he was done with BASIC, he started. I gotta check those integers, man. Gotta work on that. So okay, fine. The documentation is amazing. Like if you look at the documentation, it's like all the corporate standards that are out there, it satisfies. It's like 50 pages of documentation. It has all the right headings and footings. It's just awesome. It paginates fine. It's spell checks. You name it. It's all the good things. All the good boxes are checked. So that's pretty awesome. We have Robert Ramey, who actually should Google for his name, and ACCU. He has a great article about why checked integers are good and how to do it efficiently. And he has a sort of the boost variety of checked integers, which is all kind of big, a big proposition, 5,000 lines, 5,000 more for tests, a bunch of documentation, and it kind of cheats by using like 6 advanced boost libraries. Why are you laughing? Am I being funny right now? What movie was that? Goodfellas, right? That's a good movie. So am I being funny here? What's happening? Why are you laughing at that boost, right? It's a great library. Just it's very large. Anyhow, we have a D library, which is called checked-in. And it's actually also a policy-based design. Both of these are. In 5,000 lines of code, there's a bit of compression because those 5,000 lines of code include complete documentation. And that was my starting point in defining the following. Okay, so first of all, like, let me ask you this. Let me be sort of your salesman here, and let me ask you, how many lines of code would you pay, would you allow a checked-in library to be? Give me a number. How many lines of code? It's, you say, I want a checked integer. And I come and say, I have n lines of library code for you. And you're like, you know what, I'm not gonna, no, I'm not gonna, I don't like that. What would be a limit? 100 lines? They're kind of low, it doesn't do much, right? 5,000 lines, we kind of agreed, it's kind of a bit more. Here's my take on it. 1,000, huh? Depending if it's got to work, okay? And that's a, I think, 1,000 lines is the limit. You can, like, sit down and within like 15 minutes, you kind of have an idea. Yes. Why do we need this much code for that one bit? Right. No, reading a bit is easy. So it's actually, that's the small part. The more difficult part is making it generic so that you can plug in the library with any behavior you need. Right. Let me get into that one more minute, and probably it's going to become a lot clearer. So now here's my opinion. 10 lines of code is something two people may share, and it's kind of an idiom. It's like, 10 lines of code, I understand. It takes you like 30 seconds to figure it out. You're good, right? Except, of course, if it's in the Q language, in which case it's a web browser, right? You know the Q language? Like that amazingly compact language is like the game of life in one line. It's like just fantastic. All right, so then we get to like 100 lines order of magnitude. What's 100 lines for you? Something, it's a little library that does something. It's a little function that, a couple of functions, a little type that does something meaningful. And then we get to 1,000 lines. I gotta have a library there. We get to 10,000 lines. What is that? Framework, right? And then I get to 100,000 lines, which is Emacs, huh? No, the Emacs is much larger. So 10,000 lines. Well, what would that be? Sorry, 100,000. What would be the sort of the, huh? No, maybe a little kernel. A runtime, yeah, about the runtime would be good. But also for my, for me, I kind of tested myself. I think 100,000 lines of code is what I could manage if I had absolutely no life. It's one human being with absolutely no life could manage it. That's my opinion. Because I realistically manage like 30,000. That's about my limit of like, I know everything about 30,000 lines. 100,000 lines I could kind of extend into that. Okay, 1 million lines, what is it? It's a whole, it's a meaningful application. 10 million lines. What's 10 million lines? It's a system of systems. Linux, 100 million lines. Windows, yeah. Right, 100 million lines. Google weird project, right? Okay, so I gave myself a budget of 1,000 lines to say if I don't do it in 1,000 lines, and of course any project goes a bit over budget, you should not laugh at this, please, ladies and gentlemen. Be nice. So it's 1,200 lines of code, and we're looking at more, 900 lines of testing and 900 lines of documentation, and we have a library. And I think this is way better than looking at 5,000 to 7,000 lines of code for doing actually fewer things, because actually this does a lot more things. So now, what's the secret to this 5-to-1 compression ratio? Everybody should say static if. Yes, no, it's not only that, but it's kind of that idea. So okay, let me tell you a bit about the design of that particular library. And by the way, I said I'm insulting your intelligence, but actually I'm using a very simple example. There's no algorithms in checking integers. There's that, there's that one assembler line, and we're done with the algorithmic part. But I try to explain this to people with allocators. And by the time I say, oh, here's an interesting memory allocation architecture, and they're like, by the time I'm done with that sentence, they're like half asleep. They start snoring by the time I say, oh, you can expand in place memory, and that's pretty awesome. You should know about that. They're like, yeah, well, I'm dreaming here, right? So it's kind of it's a difficult domain, but this is an easy domain. Everybody can relate to. I want to check these integers, right? So then give me the opportunity to introduce the simple design tree, which is I have a struct which is checked and it has remember two template parameters. And by default, I'm going to abort whenever something bad happens. And I only have one extra type argument, which is a hook. And this notion here is called a template constraint, which if you just read the code and not the fine manual, what do you think it should do? By the way, bang passes arguments to a template. So what do you think this if does? Yes. It's like an std enable if, which means it restricts the things you can do with this template, right? It restricts the instantiations to only integrals, right? Thank you. Awesome. So we have this if here, and then we say, oh, private TP payload, then we have a hook. And that's my layout. At this point, please shout at me. Yell. Destroy. Yes, what? No, yeah, static if. So there is a problem here already. So we already have a problem. Remember when I told you don't want to add anything to the layout of the checked integer, and we just added the new member variable, which is going to have a size, which is going to bother us to no end. Right? How do we fix that? Now you say, static if. Of course. Oh, wait a second. So I have a payload and I have static if the hook does have state. If the state size of the hook is greater than 0, maybe the hook wants to store extra information. If it does, then I'm going to put it in the layout. Otherwise, I won't. So I have a static if this hook is has state, then I'm going to define a member variable. Otherwise, I'm going to do something interesting, which is I take the type and I create a name for it, which is the lowercase hook. So then if I write, all right, so let me consider this. So in C, for example, if you write x.fun, if it's an object, and if it's a pointer, what do you do? Right. And if it's a type, what do you do? Double colon. Right? Colon, colon, thank you. Right? So in D, all of these are x.fun. And that's an important, actually it looks innocent, but it's actually important syntactic simplification, which is going to lead us to a very easy way of doing things, because if now I say lowercase hook dot do something, it's going to take the type function or the variable, the value function just as well. So all of a sudden we have two possible designs, very interesting. And then I discover, well, what if you want to define your own default value? And here we get to a very interesting new element, has member. It's a query. Do you type have a member by that name? It's an introspective query, okay? And it happens during compilation. So do you hook have a member called default value? And I pass it as a regular string. And static if that, I'm going to say private TP payload equals hook default value of T. Otherwise, it's not going to be explicitly initialized, which makes it 0 actually. Indeed, everything is initialized. So I'm going to have this nice thing, and then I have the same thing. All right, so all of a sudden we have 4 possibilities here, kind of covering like 4 times the design space that we just had before, which is nice and interesting. Oh, by the way, default value is good for if you want to do the not a number thing for integers. So you reserve a value, initialize with that value, make sure that all computations mind that particular value. Awesome. And now the shell is going to take care of things like factors, commonalities together, interface with the type system. It's a good kind of central point of coordinating these hooks. Fine. It's not needed for all designs. In the allocator design, it just works without a shell. It's just you compose immediately. All right. How about if I'm kind of a really careless programmer and say, you know what? I'm going to instantiate check within, fine, and void. which is pretty much the stupidest type in the universe, right? Like, doesn't have any state, doesn't know how to do anything. It's a completely incapable type. Should this work? I'm gonna stand between you and the. Should this work? Yes, it should. What should it do? What should it do? It should do what int does, because there's customization. It's not realized, right? It's never actually used. So we have a customizable integer that is actually not being customized. So this should behave like a regular int. It turns out this is a great tool because it gives you a dry run through the design. Is my checked in with void going to be as fast as int, as good as int, as convertible as int? It has the properties of an int. And if it does, it means I have a good design on my hands. All right, very nice. Now let me show you the implementation of, I've chosen an example, the unary operator, which in C++ would be spelled as, if you want to implement like increment and decrement. How do you spell that in C++? You want to implement increment. Operator plus plus, you open parentheses, right? And you put an int there if you want to, like, right? All that good stuff, right? Cool. So in D, you actually get a different behavior. It's a different interface. You just have to define OP unary. And there's two sets of parentheses here. Remember when I told you there's two sets of parentheses in a function, and what does the first set do? Compile time stuff. And what does the second do? Runtime stuff, which means this operator is going to come to me during compilation. Look at that. And then let me actually limit this function to plus, plus, and minus, minus, so nothing wrong happens. And I can actually make these things during compilation. Remember, arbitrary evaluation during compilation, right? So first thing I'm going to look for is, do you actually want to do all the, you do want to hook this operator all together? And if they hook it, I'm going to call the hook. And we're done. There's nothing more following. Everything is in the else branch. So is the hook interested in completely intercepting this particular operation? If so, just no problem, forward to him. Otherwise, maybe you don't want to hook the thing, but maybe you want to be notified in case of overflow. Maybe it's only the bad things that interest you, not redefining the whole thing. In which case, I'm going to do, well, are you at the maximum? And in that case, I call an overflow, etc., etc. And notice one little detail that may actually be of interest to you. Notice that I'm assigning payload from hook.onOverflow payload. Why do you think I'm doing that particular thing? So I do say something bad happened. Overflow. It's bad. You try to increment, it went over the limit. But then you assign payload from on overflow. Yes. You give them a last chance to recover from whatever happens. They may throw an exception. They may kind of say, this computation is done. We can't. But maybe they have a thing. Maybe they want to return what? The maximum value saturate, right? Maybe they want to return nan. So they give them a chance, right? The same logic goes for the minus minus. And here, guess what I'm going to do? Remember that string? I'm not sure if it's visible from the, oh, you got that thing there. Okay, awesome. So this I wrote just because I'm a jerk. I could have just put like a static if in there, but I was just a jerk. I said, let me use a mixin right now just to give them a hard time. Make it more difficult for people. Because OP is either plus, plus, or minus, minus, and payload is going to be, oh, sorry, this is a concatenation. Sorry, I was making it too hard for you guys. Right? So this is actually, I'm concatenating two strings. One string is plus, plus, or minus, minus. One is payload, which is my member variable, remember. And this is finishing the statement, and this is actually finishing the mixing statement. Whenever you generate code, you're going to have stuff like that. Actually, I spent like the better part of half an hour with a gentleman explaining why there's a need for two semicolons there. It's not trivial. So you're gonna, you have a mixing statement, you put semicolon, fine. It must expand into a statement. And that statement must have its own semicolon because the first semicolon got eaten by the dog, right? The dog ate the semicolon. Okay. So, all right, fine, just because I'm a jerk and just because actually what happened was I didn't have room on the slide. You should know, you should know as a speaker, it's very hard to make slides because all the code must fit in slides. And you measure mentally, oh my God, there's going to be 2 slides, I'm dead here. All right, mix in, fine. So then, if you take this design to the logical conclusion, you get these optional primitives to do anything you want. You want to define the default value, the minimum, and the maximum. These are important to hook because if you have nan, you got to push min a little bit, right? If you want a nan, you got to reserve a value, and that's going to be like the smallest value. You got to push min a little bit. You got to make it like minimum plus 1, right? Then I may want to hook anything, OP cast, OP equals casting, comparison for equality, comparison for ordering, unary operators, binary operators, a clowny thing which is binary to the right, 1 plus x instead of x plus 1, OP assign, which will be plus equal and friends. Or we can implement only the event handlers on bad cast on overflow or lower and upper bound. And that is the full collection of optional primitives. Yes? Since you pass plus and minus as a string, can you implement additional operators? Should you? Of course, the wake up people say. No. So the short answer is no, and the longer answer is yeah, just comment out that's the longer answer. Just comment out that restrictive line and we'll see what happens. I think adding your own operators is a difficult proposition. Which language does it and is still controversial in the community? Yes. Haskell does it. And it's not operator Haskell, it's Haskell. Right? So Haskell, what other language? Scala, thank you. Thank you. So Scala does it, and it's kind of, I think there's controversy in the community, like it makes for quite arcane code for newcomers. So it's in the air. But anyhow, of course, everything we need to do is comment out that if, and we're good. So then I sat down and defined a few hooks just to make sure everything holds water. And you abort everything, you throw, you warn, you write to the standard error. You have a nan, you have a saturation behavior, and you define, of course, your own, which is where the fun starts. And I notice among these, which are non-trivial, the average length is 50 lines. It's not like, you don't need to define a heavy type just to get your own checking. All right, that's nice. Just by means of an example, this is a very small hook that's going to assert whenever you have a mixed sign comparison that's wrong. And, I'm telling, again, this is a 1 slide thing. I had to fit in 1 slide, so it's going to take you a while to figure all that out. It's close to Q code, right? It looks a bit like Q. But, it's not very complicated. It's just, checks all the wrong things that could happen in the assert 0, and you have a mixed sign comparison that failed. Now, that's my type. Checked in, no pesky comparisons. Now, how about this? Maybe I don't want to compile code that does it. What should you do? Alias in mind, but what mind? I mean, I gotta redefine this. I gotta define a new hook that's going to refuse compilation of wrong code. Yeah, if static if is nicer than if, then what's better than assert? Static assert. Yay! Awesome. So in this case, this is again lazily instantiated. So whenever this bad thing happens, static if, static assert, they go together, right? And you're gonna have a nice message. Mix and comparison of this type string of and this type string of. It's all concat. All these squiggly things are concatenations. Disallowed, please cast one of the operands, and we're done. And now we have like a static checking with the same infrastructure. There's no need for much more change for any change really in the architecture. Which brings me to the final topic of tonight, which is composition. The key to small code, many behaviors is composition. You gotta boil in your own sauce there, right? You gotta boil under pressure there, right? You gotta eat your own dog food. right? And that way you kind of you know the story with the Munchausen guy who kind of pulled himself out of his own bootstraps, including his horse in between his legs. He was like riding the horse in a swamp and he pulled himself by the bootstraps. You got to do something like that. So you kind of multiply your own behaviors by your own behaviors, which is weird. So let's see how we can do that. And I'm not kidding, but I did that thing. I commented code out. Here's what I actually I added a bit of code. So traditionally, this was my first design. Struct check, if this is an integral type. Boom. Fine. We discussed this so far. Yes? Now, one that I said, actually, checked should work with checked. So checked of t should work if t is an integral, or, remember arbitrary expressions. This is a keyword, it's blue. T is the same as checked of u and h with the variables u and h. Type system experts, could you tell me what this is doing? So I want to figure out if t is some checked of u and h with some variables u and h. And bind them for me, please, while at it. It's called unification. It's tree unification, and you know, advanced type systems do it all the time. You know, they match two trees and they bind the variables. Right? So is t an integral or is t some other checked? Then this is gonna go through. So I added this much code. And all of a sudden I had new designs. What's better than many designs? Even more many designs. So I fell into the pit of success. You know what that is? It's used in UI, in UX kind of things. Second, you're on your iPhone, you do something completely stupid, and oh, it worked. It did what I was expecting to do, even though it doesn't make any sense. It's kind of weird. It did what I planned, really wanted done, but I don't know, you know, how it did it. So that's the pit of success. It turns out I fell into this pit of success because I made this instantiation. It just worked. Like flag free, no problem. Boom. I got yet another thing done with the same code I had. And there's other combinations that also work. And then, you know, on the bottom of that pit of success, there's some kind of unsavory characters. For example, some combinations don't make sense. Consider, you want to abort and then throw. You know, you can commit suicide only once, friends. There's only one opportunity you got. You know, you can't like, oh, I'm gonna shoot you and then I'm gonna kill myself and then I'm gonna shoot you, right? That kind of, it doesn't work. So these combinations just don't make sense. And there are quite a few. If you throw, you're just done with the computation. And then there are a few that I found just weird. For example, if you want to warn and then do the right thing. So I want to warn to the standard error, but then I want to do the comparison the right way. Let's say I want that behavior. What do you think is going to happen here? Thoughts? It will not work. Why will it not work? No warning. Because this guy is kind of taking care of it. Actually, no, because you hook this guy. So this hook is outside, so it comes first in a way, and then it hooks this other guy. What really happens is you do the same work twice. This is like what Mozilla does. Because this guy is going to test that the comparison is wrong, and if it's wrong, it's going to log something, and this guy is going to know nothing about this other guy and is going to do it again. So there's going to be two evaluations of the same conditions, and remember, we do care about efficiency, right? So this is not acceptable. So very unpleasant, highly unpleasant. So, you know, there's a few that I can't even, you know, you can't understand what they're supposed to do. So you're a good engineer. What would you do right now? Static if. It's got to be somewhere, right? Yes. Other ideas that do use, of course, static if. Yes. Constrain the types appropriately. Yeah. So kind of if you hook, you shouldn't have another. Yeah. You can't have two hooks on the same thing. That's a very interesting idea. Actually, I pursued that design for a while until I had an even simpler idea. Yes. Compose the hooks. Find rules for composing the hooks, right? So do composition of the hooks themselves, and that would be interesting. Yes, thank you. Compose the hook, you know, build hooks from one another instead of having a hook in the final product. Cache. What? Oh, cache. Yeah, it's a nice key. I like caching. Yes. Cache the result of the operation. Okay, so that would be another possibility. I think they all are. There's good ideas here, but it's just difficult. I'm not as good as you guys, so I kind of tried the following thing. It goes the following way. We're gonna do it by hand, kind of approach, which is the following. I said, I'm gonna define my own hook, and I'm going to alias, which is create new names for existing things. And in this particular case, if I have a bad cast, I'm going to abort. This is the buffet option, right? So you go to the hotel in the morning, you have a buffet, choose whatever, put in a platter. So if the bounce checking doesn't work, I'm gonna saturate. If overflow, I'm gonna saturate. If you do the comparisons the wrong way, it's abort. And this is pretty much what I please with this particular hook. And if you want to change anything, you change one line and you're done. You're good. You're awesome. And it takes this, and actually after, because I implemented that idea that somebody gave with, do the hook prioritization and chaining, and because there's kind of existing work on that. There's art on that. People have done that kind of stuff at runtime. So even after I did all that, I said, this is so much simpler and so much more clear because the composition is in front of you. You put the add-ons by hand. Yes. Thank you. How would you saturate and warn? I thought it wasn't audible. So if you want to saturate and warn or do anything sort of more complex, you're gonna write your own function. It's not gonna kill you. You're a code after. You gotta write some code. I'm not telling you how to write zero code. You gotta have like at least more than one line to have some exponential effect there, right? Because if you want, it's like terrible. Like 1 to any power is good. Stay there, right? Not good. You want to have more than one line of code. Awesome. So here we are. So to conclude, I hope I convinced you that this is not really kind of macro assembly template expansion. It's not blind and it's not mechanical. There's a human there's a human factor in this, right? Yeah, somebody sat down and said, let me assemble these by hand. So assemble with components that are much more plastic and adaptable to one another than otherwise. We have this great notion of optional interfaces, which I think is a huge win. You can compose either automatically when it makes sense or semi-automatically. And you cover just a bunch of possible behavior with a small amount of code. That's how you get the whole checked, the whole check possible implementations in just 1,000 lines of code. It's very difficult otherwise. And it's just, you can't do it. And we have the whole graceful degradation, which means you may have components that don't know how to do things, which is totally fine. It means the resulting design does fewer things. You've been awesome. Thank you very much. You've been awesome. Thank you. All right, so how are we on time? We're in good shape, right? We can take questions, right? Questions. Don't ask me if I like Rust or D. Between the two, please. Yes.
I'll give you a second chance to answer a question I asked you 5 years ago, but now it's a little bit less appropriate. Would you say that D is the small language trying to emerge out of C++?
Do I think D is the small language emerging from C++? I'm going to open this to the floor. Do you think D is the small language that was struggling to get out from C++? There is a famous quote by Bjarne Stroustrup who said, inside C++, there's a much smaller language struggling to get out. Fewer keywords. Small means, for example, smaller grammar, fewer semantics. Sorry? a shorter book. Yeah, the length of the book would be shorter. And modern C++ design would be a brochure, that kind of stuff. In my opinion, this is a whole different language. You don't do that in the large C++. I mean, you can't even do it in the smaller version of C++. You would have to grow C++ to get to the right. Right, it's even less appropriate right now. So do you have a life, and what's your wife doing? So other questions? Yes.
Yeah. So my question is, when you're constructing these types, how do they interact with each other? Because each one is a different type. So say I want one part of my code to abort and another to warn, then you have problems across time and the sizes.
So what happened? Again, I'm gonna open. I just discovered a great public speaker technique. Whatever question I get, I open to the audience. What should happen if you have two checked integers and you want to add them to one another? What should happen? Yeah, with different hooks, different types. They're going to be unrelated as far as the type system is concerned. And you want A plus B, and they're checked just in different ways. Yes. Convert one of them to the other. Which of them to whom? Decide. Pick one. Non-deterministically. How about that? That'd be awesome. Yes.
I suggest two ways. The C way is convert to the less to have a result most likely, and the Java way is convert it to have less likely.
Right. So there will be the C way and the Java way. Like the C way do like what could cause the most possible damage. The Java was like the most annoying, right? Okay, I understand. Yes. Why does the hook be on the type and not on the action? Actually, the hook is a type that defines a number of canned actions. There's different hooks, right? Mm-hmm. So, okay, so you have A plus B. A plus B, both are interested in the overflow event. If any overflow happens, let me know. But they both want to know about that in different ways, okay? And what do you do?
I would implement a monoid, like and ask, let the
A monad.
It depends on the result. If the result is a variable, then you've got it based on that, and you're basically, in least the case of integers, at least in the general case, maybe it's not clear. In the case of integers, the underlying type, especially if they're the same size, is straightforward. The only question I would have is if you use the expression of the result, and it's not assigned to an integer, not assigned to a variable.
All right, but people, what they do indeed, they say auto x equals a plus b, so they let the type system just do it for them. Okay, fair enough. Yes, other. So let me repeat the answer just for the screen. So you may have a way, you need to have additional hook functions for defining how they convert to each other, right? Okay. Maybe they have to be the same, and if not, they compiles. And you know what? I'm seeing nods in the audience. You know what? That's what I did, friends. I didn't have I'm honest, I didn't have a better idea, and I said, you know what? There's gonna be a compile time error which is gonna tell you, please add .get to one of the values, so you convert it to the underlying representation. So instead of writing a plus b, you're gonna have to choose. You say a.get plus b, or you write a plus b.get. And by the way, in diff, there's only the parentheses, so you don't need to put them. Yes. Yes, with literals we're lucky because you say a+1, and it just means you just pass operator. You pass one to this guy's operator. So if one of them is built in, you're good. The problem happens when you have two guys both checked in and they have different checking policies. Actually, if they're the same type, there's code in it that makes it work. Other questions? Just as a comment, I like that you guys have these ideas, and all of these are some things that are going to keep you at night, hopefully. Yes. What if they're the same types, but the hooks are stateful? The left guy is going to take. I'm not kidding. Actually, this is what's going to happen. The left guy is going to take precedence. Don't you hate me right now, right? It's like, oh my god. The left hand side is going to take precedence. Yes. Yes. Do the parentheses, are the parentheses optional because it's a property or because of syntactic sugar? There's a bit of a story behind this. How much time do you got? So what happens if you write in C or C++? In C++, for example, you say x dot function, and you don't put the parentheses after that. What happens? You take the address of the function. How often do you want the address of the function as opposed to calling it? No. It's not a delegate. It's almost a delegate. It's not what you want it to be, right? It's some weird. It's that pointer to member function thing, which is like is remarkably useless, right? It's a sorry. It's not a bound pointer. Oh yeah, you gotta take like the type, right? Capital X, that fun, right? Oh, so it doesn't even work. Even better. Okay. So anyhow, so the short of it is the following, ladies and gentlemen. It's if I say x.fun and put no parentheses is the least useful behavior. Do you agree with this? All right. So indeed, we're like, what if we make that the most useful behavior, which would be called the blessed function? For me, thank you very much. And this actually turned to work. And actually, it's very important because when you have these long chains and stuff, it's going to save you a lot. If you look at the code before, I'll see Liran kind of nodding like, you see this on my forehead right now. This is because of all the parentheses I had to write. And those are not the least fun parentheses. Those are like the bad parentheses, like that, like bananas, right? Like, Eiffel has the same thing, yes. So I love this because whenever I give a talk about this stuff, I mention this, and I really like, I plant the seed. I kind of throw like a dart with poison in it. And the equivalent of doing that in C++ is I just mentioned there's this very interesting macro that I wrote. I'm not going to talk much about it, but there's this interesting macro. It does the following, but I can't tell you how it was. Contact me offline. That's how I get most of my business. Like everybody's like, oh, about that macro. So I present like interesting things during programming, all these good things, and at the end, inevitably, it's gonna be about that macro that you talked about. How do you do it? What's the secret? Questions. All right. So here's what I'm going to do right now. I'm going to pass the microphone to Liran because he wants to captive audience, right? He's going to tell you a few things about how Weka.io uses the D language. But before that, I'm a sucker for applause. So thank you very much. You've been great. Thank you. Thank you.
All right. So actually, I don't look at it at promoting Weka.io, but more of promoting D because it's a very important thing for us, and that's the reason we've asked Andrei to come to Israel. So just as an affirmation to the thing that this is a real programming language, it does real work. it helps us get our work done, and actually a lot better than we anticipated. So just so you know that we're a real company. Weka.io, we have an R&D center here in Tel Aviv, our headquarters, and when we're doing our business is actually in California, San Jose. We've raised Series A and B from large venture capitals. We have a lot of experience in doing storage. Actually, a lot of the team came from the XAV team, from the military intelligence, a lot of Aramnics, if you know the name, and NetApp, Intel, EMC, IBM, many other companies. What we're doing, we provide a scalable storage system that basically is going to be it's like a three-dimensional thing. Scalability is how big the circle is. So we're going to give you the performance of an all-flash array. We're going to cost about as an object storage, and we're going to be scalable as an object storage, which basically gets you the best of all worlds. And it's 100% software based. It runs on a cloud. Not only it runs on a cloud, it runs right on a public cloud, so it doesn't even have to be your own cloud, and it's massively scalable. Any amount of files, any amount of files in a directory, and you get the great performance. What does a storage system have to do? So when you decide to implement it, what feature you need to think about and help you pick your programming language. So storage first has to be extremely reliable, because storage is the only thing that has state in the data center. So anything else that doesn't work gets rebooted. It gets its state from the storage. If you try rebooting a storage, you're gonna have a busy evening. So it just has to be there. And if you store petabytes or exabytes, these are quite a lot of bits in it. Users expect all the bits to be there in the same order. It's harder than it seems, because your hardware basically has a bare bit error rate of about 10 to the minus of 16, 17. So every day when you're moving data at gigabit speed and you're storing petabytes, you have quite a few of wrong bits going there. The users are unaware of it. They don't know they were cheap. They didn't buy the right hardware, so just flunks. By the way, you cannot buy the right hardware. Any hardware you would buy would have it. But we have to make sure that when you give us the bit, when you think you actually gave us the bits, we made sure these are the right bits. We store them. When we return them to you, it's actually the same bits. It has to be high performance. So in very high performance implementation, we have to get the data back to the users in about 100, 150 microseconds. So there aren't that many CPU cycles, and it has to go several times through the network and these other things. And people like features. So you take a snapshot, you want replicated, you have quite a lot of directories, a lot of files. So these are complex things. So it's not just takes a lot of this, and of course these are distributed programs. So the language has to be very efficient to program, very descriptive in nature. So this, for example, takes quite a lot of options from the table. For example, C++ is not very efficient to program, because in order for you to program C++, you would have to, so just reading Bjorn Stroustrup's book won't make you a C++ programmer. You have to read effective C++, more effective C++. If you care about STL and Boost, you'd have to read the books about them. If you care about throwing exceptions, then you have to read the books about them. So, and then you have to think about all these things. So getting to be effective and efficient in program C++, it's very difficult. Now there is another contender. Nobody actually asked Andrei about Rust. So he forgot about it, which is a great thing. But when you look at Rust code, you have to invest quite a lot of effort in convincing the language what you're doing, and you're not getting that much expressive power. So the The language has to be very efficient to program. It has to be fit for large projects. And actually, I didn't put it there, but it has to be efficient. So Andrei on his talk said there is no space on the bottom. You don't have to go over to C. And then he gave our robbing hash example. Actually, the kind of things that we're doing with static ifs, so the kind of thing that we're doing with static ifs, with our very efficient packing, with a very efficient choosing of algorithms, are basically only available in D, and they actually allow us to get better performance in D than what you could get in C or C++, because you have no way of expressing these higher level concepts and getting closer to the CPU. So our data structures pack themselves in cache lines. How easy it for you to write a generic data structure that is always well packed in a cache line? And then when you traverse it, it hacks faster. If you wanted to do it in C, it would probably take at least 10 times the amount of code that we do it, and you would have to do it each time for each of these implementations. So I'll very quickly go through our D experience, and then I'll be able to answer some questions or give it back to Andrei or get you back to Mingle. So one thing that we hoped for, and actually we achieved extremely well, is that our programmers are extremely efficient. I don't think it would have been possible to get our current state of the project with our current state of the features with a different language. The language is very powerful. We're actually using LDC, which is the D front end on top of LLVM, so we get great optimized code. If you just download D from the internet, you're going to get DMD, which would compile extremely fast, but would produce unoptimized code. If you want your code to run fast, then you should do it with LDC, and then LLVM will optimize it for you. And as I said earlier, because we're able to run so much logic inside the compiler, we're able to generate the right code, and actually we're able to insert the right semantics into the code, so the optimizer would be able to do a better job of it. And this is a test I did today. I didn't even tell Andrei about it. I looked at our current count of codes, and I looked at the count of codes we had a year ago. And nowadays we have a lot more features. So if you asked our customers whether we have more functionality, they would tell you that we have immensely more functionality, magically, or not magically, but thanks to the static ifs and the other features of D, it's about, within 5%, the same amount of code that we had a year ago, but we're doing a lot more things, which is great. And really, I don't see any other option that would give us the same expressive powers of D and get the same performance, both of our executed code and our engineers. So that's my experience. Thank you very much. So if you have any questions about practically using D, I'd be very happy to answer, or there are quite a few of WCAG people in the crowd. You can ask us later. Yep. So we have two. So the question was whether we use GC or we don't use GC, the garbage collector, in our code. So running GC, part of the data path, is obviously not an option for us. But GC helps us in two other ways. A, when you prototype, then writing D with GC is immensely easy. It's comparable to writing your code in Python. It's as expressive. So it's very easy to start a feature. You get all the benefits of the GC, and once you've got the features right, you don't have to put mental stress, mental energy while you're writing your features, thinking about the details, when you got them right, it's extremely easy for us, because we have the infrastructure, to go over there and remove the GC. Then, on the other side of the spectrum, we have clustering code, management code, things that don't have to get back to in 100 microseconds, and there we use the GC. We have no problem with it. So the GC, even for us, the GC ended up being a good thing. Any other question? All right. Thank you very much. Go Land D.
Yeah. Actually, the GC was a good question. Yeah, it was a great question, and you answered it well. Hello. I haven't met Andrei. Hi, Ben.
I do some as a hobby, some embedded programming. I understand that there is ideas to try and make things use less GC in the standard libraries, more things that be used. But is that actually pursued by anyone backing, or is it more of the idea in the community? The second question is Facebook, as I understand, there is debugging, but it's not that most people use C++ in general. Is that, are you trying to change that, or is that an idea people have?
To the first question, actually, we're in a much better position right now than we were a year ago, because a year ago we didn't have a solution for no GC and safety. Turns out it's very important. As this fine gentleman is going to tell you, safety is very important, right? So it's easy to have safety with GC. It's easy to have no